Hi, welcome back to my channel. Hope you are doing good. Today I am going to talk about Kubernetes resource quota and limit range. This comes under part 8 in my playlist videos. So let us dive in. So before we try to understand resource quota and limit range, we need to understand about our computer CPU resources. So what are computer CPU resources? You know that CPU has cores, memory, motherboard, all those things. Whenever we are going to host anything on the computer hardware, say OS is essentially required some disk space to install the software. To perform better, you need to have good amount of memory, right? The same way, uh, we are going to host applications in the Kubernetes engine. So Kubernetes engine also is going to depending on the CPU resources. So that's the reason we were talking initially about CPU resources, and then we will go further to understand how do we configure resource limitations. CPU hardware core units and memory, that is random access memory. We are all aware of it. So one CPU unit is equivalent to one physical core or virtual core. How we are going to host it as a cluster. So nowadays you know that there are a lot of virtualization technologies available. You can use the virtualization and you can create virtually the CPU cores which can perform any kind of operations. So one CPU in terms of a mathematical calculation 1000 millicores. That means one of the core can be decomposed into thousands of milli CPUs. So Kubernetes is going to give you more flexibility when you are building your application. You don't need to consume the entire CPU or entire memory which is supporting from that hardware. For example, people will call in the organizations a node or computer that contains 16 cores, 32 GB RAM, something like that, right? The same way, even whenever we are hosting any cluster is nothing but group of compute nodes. Each compute node will have CPU cores and memory, that is RAM. So cluster can be hosted in the same LAN or in different LAN. You can bridge between these two through a router and then which can be communicated. If you want more details, please search from the Google, or I have created one of the basic video. You can try to listen that. Now let us understand what is a resource quota. Why do we need it? So as I said, in the Kubernetes infrastructure, there could be many application owners, they can host their applications. So you have to segregate the resources from the total resources. The resource quota is the total allocated resources for a particular namespace. Whenever we are deploying any type of application in the Kubernetes, we come up with the application specific namespace. So we are going to bound the limitations on that namespace, how much this particular application owner can utilize the resources from the Kubernetes. Okay, so that why do we need? As I said, we don't want to give say 32 GB RAM, 16 cores to a specific team. So we can classify as per the demand from that application and then we can allocate. So let us consider here there is a capacity of 32 GB RAM and 16 cores as one hardware. Let two teams going to share that hardware. Use 20 GB RAM, 10 cores for team A, and team B let it use 10 GB and 4 cores. Still the hardware remaining 2 GB and 2 cores, if you can leave it for the operating system to up and running or reserve it for the future allocation running within the namespace engine. That's how you need to segregate. Who is going to do? These are all doing by the administrators. So Kubernetes resource quota also limits certain objects which we are creating. That also you can limit it. Not only applicable to CPU and memory. Okay. What are those objects? You can limit how many pods you want, how many config maps you want, services, deployment, replication set, replication controller, all those things also can be controlled with the specific numbers. Okay, if resource quota is there, then what is the point of a limit range? Resource quota is applied to the namespace, but limit range is applied to the specific to the containers. So maybe as per your application required, specific application, say Java based server, more than in a 64 MB RAM is needed to serve for that particular application, then you can go ahead and set it up commonly, whether you wanted to use the default configuration CPU memory limits, yes, you can go ahead and define, or minimum maximum you want to define, yes, you can go ahead and define. That's how single pod cannot consume the entire resources. That's the reason it is talking about. Limit range used to assign limits for the objects like containers. Example is pods. Why do I need the limit range? If we don't allocate limits, then the single object monopolize all available resources within that namespace. It will not give to other pod to share the resource effectively. Only it itself consumes it. That's the reason we go ahead and set the limitations. Who is doing it? An administrator can go ahead and create resource quota and limit range as per that application. For example, here we can consider 2 node cluster with a capacity of 8 GB RAM and 16 cores. Constrain pods in the namespace to request 100 milli-CPUs and maximum limit is 500. And request limits for the memory 200 MB and maximum limit is 600 MB. That means always the limits is a higher number, upper boundary, the requests are lower boundary. That is the default significance as an developer should be aware of. So in my exercise, I am going to demonstrate. I'm running a Windows machine, VirtualBox running, which is Linux operating system. Inside the Linux operating system, which I am running a Minikube engine where I'm going to host Spring Boot based application, which is running on 8080 port. So these are the prerequisites to test this. And intended audience, experienced developers or whoever would like to host the applications onto the Kubernetes engine. These are the reference links. Let's jump into the real hands-on session. So here I have defined the limitations, resource limit. I am telling that I'm going to assign it to a specific namespace the limitations. The kind type is resource quota and the name is CPU mem quota, which I'm specifying, and I'm saying that it is a hard limits. Okay, request CPU 1 core, request memory 1 GB, limits CPU 2 cores, limits memory 2 GB. That means limits always upper bound, request always a lower bound value. This is how you can define the resource quota. Let us understand limit range. So this is the limit range kind. This is the name of the limit range which I am going to post it. In the limit range, you can have variety of the things. default limits we can define, default requests you can define, minimum and maximum also we can define. If you look at it, the default limits are CPU is 500, memory is 128 MB. That means this is the total allocated for that specific namespace. Out of this, we are going to allocate specific to a pod level. And default request CPU limitation is 100 milli-CPUs. Memory is 128 MB. Maximum quota I am defining 1 CPU core and memory is 500 MB. Minimum is 100 milli-CPUs and memory is 64 MB. Which type? To a container. Okay. So if you do not specify when you are creating your deployment or pod, by default this will be applied, these two, because this is a default thing. Now let us understand my deployment. So this is my basically the pod deployment based kind. So you can see all these things. Now I'm interested to aware of this section. In case if you are not going to specify, say container Java web, I'm pulling from the public registry, that is the Docker, and I'm assigning to bind and resources. If I don't specify these resources here, it will be applied from the limits range, whatever default numbers which I have given. In case if I wanted to significantly specify, yes, I can go ahead and specify with respect to deployment. Now let me try to host this into my Kubernetes. My namespace is real-time. I'm going to check, is there any resource available already? I can see that there is no resource, it is completely empty. So first what I'm going to do, I'm going to apply the resource. That means I'm going to define the quota. So if you want to test how my quota was, you can see that limits hard for CPU, memory, whatever I have allocated. You can see as of now nothing has been used it. Now let me host limit range. Now I'm hosting, let me describe my limit range. I can see that the container for the CPU 100 milli CPUs minimum, maximum 1 core. Like 64 MB is the minimum, maximum I cannot go beyond this limit, that is 500 MB. Default request 100 milli CPUs 128 MB. This is default. Limits always should be upper bound, request must be lower bound. In case if I want to resource ratio, yes, we can define. In this exercise I am not defining it. So I hope you are clear with the resource quota and limit range. Now let me host my application into the same namespace, that is Java Web Deployment -HPA. Now I have hosted, whether my application hosted or not, I'm not sure. So what I wanted to do, I can go ahead and get all in that namespace. Now I can see that there is a pod which is up and running, there is a deployment, and there is a replica set. Now let me go ahead and describe the quota. Now you can see that used is 500 milli CPUs and 200 MB out of 2 GB hard limit. Okay, and CPU request is 100 milli CPUs and minimum used is right now 100 MB. So out of 1 GB, that means remaining 900 MB still available and remaining 900 milli CPU still available for the request. But maximum limits, only this is the limit. I cannot go beyond this hard limits. Okay, so this is the hard limit 2 and 2 GB. So I set it up currently usage level at this. This is how you can control your operations and perform the mathematical calculation as per your application needs. Okay, I hope you understand what is resource quota, limit range, why do you need it. Okay, so I come up with a new video. Until then, see you. So I would request you to like it, share it, comment it, subscribe it. Stay tuned for further updates. Thank you.